Hello guys, welcome to Apex Math. My name is Bino. In this video, we go through question 2 from the April 2025 N6 Mathematics question paper. Question 2.1, we integrate the following function and we rearrange, and this will be equal the integral of x squared. We move the e raised to the power negative 3x from the denominator to the numerator, and the exponent will change sign to positive 3x. So we have e raised to the power 3x multiplied by dx. To integrate, we have to use integration by parts, and because of that x squared, we have to use integration by parts twice. But we can avoid using integration by parts twice by using the table method of integrating by parts, where we have d for differentiation and I for integration. And between the x squared and the e raised to the power 3x, one of the functions will be the d and the other functions will be the I. So we decide between the x squared and the e raised to the power 3x which function will be the d and which one will be the I. We use the eyelid rule, where the I stands for inverse trigonometric function, and the L stands for logarithmic function, and the A stands for algebraic function, and the T stands for trigonometric function, and the E stands for exponential function. The x squared is an algebraic function and is represented by the letter A. The e raised to the power 3x is an exponential function represented by the letter E. The first one between the x squared and the e raised to the power 3x is the A. So the A will be our D. So we have that A as the first one which appears, and the E appears later. So the x squared will be our D since it appears first, and the I will be the e raised to the power 3x. On the D side, we differentiate, and on the I side, we integrate. So the derivative of the x squared is equals to 2x, and the derivative of the 2x is equals to 2, and the derivative of 2 is equals to 0. So we can stop here. We move to the other side, where we only integrate. The integral of e raised to the power 3x is e raised to the power 3x divided by 3. The integral of e raised to the power 3x divided by 3 is equal e raised to the power 3x divided by 3 multiplied by 3. But 3 multiplied by 3 is equal 9. And the integral of e raised to the power 3x divided by 9, which is equal e raised to the power 3x divided by 9 multiplied by 3. But 9 multiplied by 3 is equal 27. We are now done with the table. Remember, we had the integral of x squared multiplied by e raised to the power 3x dx. So this will be equal, so we go diagonally. We start with the x squared, so that x squared will multiply with e raised to the power 3x divided by 3 diagonally, and the 2x will multiply with the e raised to the power 3x divided by 9, and the 2 will multiply with the e raised to the power 3x divided by 27. We multiply the ones which go diagonally, so our integral will be equal that x squared multiplied by e raised to the power 3x divided by 3, We will focus on going diagonally for now, and at the end we are going to have the integral of that 0 multiplied by e raised to the power 3x divided by 27. The 2x goes diagonally and it multiplies with the e raised to the power 3x divided by 9, and we go diagonally again, and that 2 multiplies diagonally with e raised to the power 3x divided by 27. The first sign between the terms will always be negative, and the second one will be positive, and the third one will be negative, so they rotate like that. And since we can't go diagonally anymore, we have to go horizontally. So we are going to have, so horizontally we have the integral of that 0 multiplied by e raised to the power 3x divided by 27 dx, but that 0 multiplied by that function will be 0, and the integral of 0 is 0. With that removed, we have our constant c. And this will be our answer using the integration by parts table method. You can tell me what you guys think of this integration by parts table method in the comment section below. Question 2.2, we integrated the following trigonometric function, and we are going to rely on our formula sheet for the trigonometric identity, and we are going to take the one which has sine 2a. So we have that 2 and that 2. Our a is the 3 divided by 2x, which will be multiplied by 2, and our integral will be equal the integral of the sine of 2 multiplied by a, but our a is equals to the 3 divided by 2x, but that 2 and that 2 will cancel out, and this will be equal 3x, and will be raised to the power 4 dx. We rearrange our integral and break that 4 in the exponent, and we are going to have the integral of, we break down the 4 and express it as sine of squared of 3x, and all of this will be raised to the power 2 since we broke down that 4 dx. We use our formula sheet once again, and this will be equal the integral. So for that sine squared 3x, we use our formula sheet, and we are going to use the one which has sine squared. So that one is equal to the half minus half cos 2a. So we have half minus half multiplied by cos 2a. Our a in this case is 3, so the 3x multiplied by 2. So our 3x will be multiplied by 2, and it will be equal 6x. And we raise this to the power 2 dx. We can expand and have half minus half multiplied by cos 6x multiplied by half minus half multiplied by cos 6x. So we can do that, or we have the integral, so that half raised to the power 2, so that half squared will be equal 1 over 4, and that 2 multiplied by the half multiplied by negative half cos 6x will be equal a negative half multiplied by the cos of 6x, and the negative half cos 6x raised to the power 2 will be equal positive 1 over 4 multiplied by cos squared of 6x. If you're not comfortable with this method, you can continue to expand, and we have the dx. This will be equal the integral of 1 over 4 minus 1 over 2 cos 6x plus 1 over 4 multiplied by cos squared 6x, and we use our formula sheet, and we have that formula for cos squared a is equals to half plus half cos 2a. So this will be, so we multiply this by half plus half multiplied by cos 2a, and our a is 6x, so 6x multiplied by 2 will be equal 12x. Dx. So let's simplify one more time before we can integrate, and our integral will be equal a quarter minus half multiplied by the cos of 6x, and we distribute the 1 over 4. 1 over 4 multiplied by half is equals to 1 over 8. So we have 1 over 8 plus 1 over 8 multiplied by the cos of 12x. Dx, actually we simplify one last time, and we have the integral of the 1 over 4 plus 1 over 8 will be equal 3 divided by 8, and we have the negative 1 over 2 multiplied by the cos of 6x plus 1 over 8 multiplied by the cos of 12x. Dx, the integral of 3 over 8 with respect to x is 3 over 8x minus half multiplied by the integral of cos 6x, which is equal sine 6x. If we were differentiating, we are going to multiply by the derivative of 6x, which is 6, but we are integrating, we are now going to divide by the 6, the derivative of the 6x, plus 1 divided by 8 multiplied by the integral of cos 12x, which is equal sine 12x. And if we were differentiating, we are going to multiply by the derivative of the 12x, which is 12, but we are integrating, we are dividing by the 12, plus the constant c, and you guys will simplify this answer. Question 2.3, we integrated the following, but before we can integrate, we are going to complete the square. We simplify by completing the square. We focus on the 12 minus 6x minus 3x squared for now. We forget the integral and simplify that, and then we integrate later. We rearrange it in standard form as negative 3x squared minus 6x plus 12, which will be equal, before we can complete the square, the coefficient of the x squared has to be 1. So we take the negative 3 as our common factor. We have negative 3 into x squared plus 2x minus 4. Now we can complete the square. We have the negative 3 into the x squared plus 2x. We plus this with the coefficient of the x, the 2. So we take that 2 from the coefficient of the x, we divide it by 2, and we square the whole thing. In order for us not to change the original expression, we are going to minus what we just added. So we minus the 2 divided by 2 raised to the power, so that it looks as if like we just added a 0, minus the 4 and we simplify, and this will be equal negative 3 multiplied by x squared plus 2x plus 2 divided by 2 is 1, and we don't remove the square, minus 1 squared minus 4, and this will be equal negative 3, and just that the x squared plus 2x plus 1 squared only will simplify to x. We take that sign from the 2x, we drop it down, so x plus the 1, all of this will be raised to the power 2, minus 1 squared, which is minus 1, minus 4. And this will be equal negative 3 into the x plus 1 squared minus 1 minus 4 is equal minus 5. Now let's distribute the negative 3. So we distribute that negative 3, and this will be equal negative 3 multiplied by x plus 1 squared. Negative 3 multiplied by negative 5 will be positive 15. We have now successfully completed the square, and remember that this is equal to the original equation that we had inside the integral. Remember that we had this integral. Let's copy and paste it. We will remove the 12 minus 6x minus 3x squared and substitute. So we start with that positive 15 because of the formula that we are going to use. We have that 15 first minus 3 multiplied by x plus 1 squared. We use our formula sheet, and the formula that we use is the one which has negative inside the square root, in the middle of the square root. And from our formula sheet, we have a squared and b squared, and we only have 15 and 3. Suppose that we had 4 instead of 15. This was going to be written as 2 squared, and our a was going to be equal to. Now that we have 15, we are going to rearrange it as the square root of 15 squared. And the a in this instance will be equal to the square root of 15. So we rearrange our integral and write it as the integral of 1 divided by the square root. So the 15, we write it as the square root of 15 raised to the power 2 minus the 3. We rewrite the 3 as the square root of 3 squared, and we have the x plus 1 squared dx. And now we match what we have there on our formula sheet, and this will be equal 1 divided by b, but our b is equal that square root of 3. So 1 divided by the square root of 3 multiplied by the arc sine of b. Our b is equal to the square root of 3, and we have in the place of the x squared we have the x plus 1. So we take that x plus 1 divided by a, where our a is equal to the square root of 15. Plus the constant c, and this will be our answer. Question 2.4, we integrated the following trigonometric function, and the first step will be for us to break down and express the cos raised to the power 5 of half x dx, and we express it as the integral of cos raised to the power 4 of half x, and we multiply this by the other cos which is remaining at the cos of half multiplied by x dx. We further rearrange our integral and break down the cos to the power 4x as cos squared of half multiplied by x raised to the power 2 multiplied by the cos of half multiplied by x dx. We are going to use a trigonometric identity to express the cos squared of half of x. So the trigonometric identity, sine squared a plus cos squared a is equals to 1, and cos squared of a will be equal 1 minus sine squared of a. So in the place of the cos squared half of x, we have 1 minus sine squared of half x, and this will be raised to the power that 2. We multiply by the cos of half multiplied by x dx. We are going to use the u sub method, and we let u equal the sine of half x we differentiate the u with respect to x, and the derivative of the sine is equal to the cos of half x, and the derivative of that half x will be equals to half. We multiply this by the derivative of the half x, the half. We multiply both sides of the equation by dx. That dx and that dx in the denominator will cancel out, such that du will be equal. So let's start with the half multiplied by the cos of half multiplied by the x dx. we can realize that we have the cos of half of x dx. Even in our integral, we have the cos of half of x dx. Let's multiply by 2 so that we can remove that half. So we have 2 multiplied by the du will be equal, we remove the half, and this will be equal the cos of half of x dx. Now back to our integral. We had the integral of 1 minus sine squared. So in the place of the sine, we substitute u, but the sine was squared, so even the u will be squared. This will be raised to the power 2. In the place of that, we substitute 2 du, because 2 du is equal to cos of half of x dx. So we multiply this by 2 du in the place of the cos of half of x dx. This will be equal, so we take that 2 out of the integral. So we have 2 times the integral of, so we can expand and have 1 minus u squared multiplied by 1 minus u squared. Or the 1 squared is equal to 1, and 2 multiplied by 1 multiplied by negative u squared will be negative 2u squared, and the negative u squared will be positive u to the power 4 du. Now we can integrate. We have 2 multiplied by the integral of 1 with respect to u is u, minus 2 multiplied by the integral of u squared, which is u to the power 3, divided by 3. The integral of u to the power 4 is u to the power 5, divided by 5, plus the constant c in the place of the u. So this will be equal to 2. So in the place of the u, we substitute back the sine of half of x. So we have the sine of half of x minus 2 divided by 3 multiplied by the sine cube of half times x, plus the sine power 5 of half of x divided by 5, plus our constant c. Now we distribute the 2, and this will be equal to 2 multiplied by the sine of half of x minus 4 divided by 3 multiplied by the sine cube of 1 over 2x plus 2 multiplied by sine to the power 5 of half times x divided by 5, and we have our constant c, and this will be our answer. Question 2.5, we evaluate the following using integration by parts, and the formula from the formula sheet is the integral of f of x multiplied by g prime of x dx is equal f of x multiplied by g of x minus the integral of g of x multiplied by f prime of x dx. So this formula needs 2 functions and we only have 1. So let's maneuver and have a second function. So we have the integral of the ln of x divided by 3, and the second function will be 1. So we multiply by 1 dx. So one function will be equal to f of x, and the other function will become the g prime of x between the 1 and the ln of x over 3. We use the Eilate rule, and the logarithmic function comes before the algebraic function. So the logarithmic function will be the f of x since it comes first before the a. So the ln of x over 3 will be the f of x, and the g prime of x will be equal to the 1. We differentiate the f of x and integrate the 1. We differentiate the f of x to get the f prime of x and integrate the g prime of x so that we can get g of x. So let's start by differentiating the f. The derivative of the ln will be 1 divided by x. We can rearrange the ln and write it as the ln of x multiplied by 1 over 3. So the derivative will be, let me erase that. So the derivative will be 1 divided by the function which is inside the ln, the x multiplied by 1 over 3, multiplied by the derivative of the function inside the ln. The derivative of x multiplied by 1 over 3 is 1 over 3. So the 1 over 3 and that 1 over 3 cancel out, so we can just erase them. And on the other side, the integral of 1 with respect to x will be equal to x. We substitute into that formula for integration by parts. So the integral of the ln of x divided by 3 dx will be equals to f of x multiplied by g of x. The f of x is the ln of x over 3, and the g of x is the x. So let's start by writing the x, and we multiply it by the ln of x divided by 3. Minus the integral of g of x multiplied by f prime of x. The x multiplied by 1 over x dx, and this will be equal x multiplied by the ln of x divided by 3 minus the integral of x divided by x. So that x will cancel out with that x in the denominator, and we have 1 multiplied by dx, and this will be equal x multiplied by the ln of x divided by 3 minus the integral of 1 with respect to x, which is equals to x, plus the constant c. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like, and share the channel if you find this content useful.